we'll talk about a few things. Just want to wait to see if anybody else joins. Maybe not. So I just put this up this morning, this Z-score practice, and I'll go ahead and open it here so we can look over it. I put it under the assignments tab. Okay.
Just have a question. I was trying one right now, and since is it possible to have a negative Z-score?
Yes. Yes,
Okay.
it is. That's exactly right. And so why you would have a negative Z-score would be that that person is below the mean.
Okay, yeah.
Okay, so yeah, if you have a positive Z-score, you're above the mean. A negative Z-score would be below the mean. So yes, negative Z-scores are completely and totally possible. When you will, and we'll go through the assignment right now. We'll look at it because this brings me to another thing that I want to make sure we know. Let's see. So a couple things. Wednesday, that class, that Zoom class or the recording, I can't find it on my computer. I have on Wednesdays, I do in the morning, I do the 11 o'clock statistics class. And then following, I have a human growth and development class. And so I don't know if it was something that happened with that. But when I went back on my desktop was only the human growth class, and I couldn't find the, I searched everywhere. I don't know why it didn't save. And so I apologize for that. And I don't know if anyone was on the Wednesday class. We went a little bit further and we started talking about percentiles and percentile rankings, but I think it's okay. But I was kind of bummed that I wasn't able to put that video up. But we'll go beyond this. We'll get into the percentiles. I put this up so we can really go over the Z-scores and finding the Z-scores and looking up those percentages in the Z table. And just get that information down. And I just don't want y'all to stress about the exam. I mean, I know there's natural stress with an exam anyways, but I was just having this conversation with my husband that this is such an unusual scenario. I've never taught stats online. I can't imagine any of you all went into this going, yeah, I want to take statistics online. I'm sure all of you all wanted face-to-face. So trust me when I say that I am very cognizant of that. I'm very aware of that. And I'm aware that added stress for you guys. So, I'm thinking like maybe the exam, I could just kind of extend the time. And so it's more like it's just something that you're working on, you're, almost like an assignment, rather than that time crunch and you feel that pressure. So just know that I am aware. I'm going to see how everyone does, and we will take it from there. So just don't stress, try your hardest. Okay. So let's go through, I'm going to go back and forth between this and the slides, just so we can see where these are coming from and how we figure these out, okay? I won't go through all of them because I really do believe that you trying them, you find little problems that you might have. If you just watch me, it's easy and it 100% always works out. So I want you guys to do it so you can catch yourselves and go, oh, that's the part I don't understand, okay? So this, let's just scroll through it real quick. All of these are just examples and little problems of finding Z-scores. okay? And I'll go back through it. Don't worry, we're just looking at it first. These are just questions like understanding what a z-score is and what it is when we're looking at a z-score. So this one, oh, I hate that the formatting there kind of messed that up. Sorry, guys. Word and tables never work very well. But Natalia, this makes me think of your question. So this one says a z-score of 2.5 indicates a raw score that is A, close to the mean, B, much smaller than the mean, C, much larger than the mean, or D, 2.5 times larger than the mean. I'm not going to put you on the spot there, but a positive z-score is bigger or larger or above the mean. Okay, if that question was a z-score of negative 2.5, then we'd be looking at a z-score that is much smaller than the mean. Okay.
For that one, how would you know if it's so in general a z-score that is positive, is it doesn't actually mean that it's larger than the actual mean? Because how do you know what is the mean exactly to identify?
Right. Yeah, good question. Good question. And I see where you're going with that. Like, how do you quantify much larger, right? And things like that. So this, it's kind of a little bit of a tricky question. You could always say it's larger than the mean, and you could always say it's smaller than the mean. A negative is always going to be smaller than the mean, and a positive is always going to be larger than the mean. Now, if you remember in that distribution, or in that z distribution, right in the middle where the mean would be is actually a z-score of 0.
Like the 0 is like your mean, the 100, so it's large. Yes.
You got that now? Yeah, so the right in the middle would be 0. So if we had like 0.25, it's larger, but I wouldn't say it's much larger, right? Actually, a z-score of 0.25 would be very close to the mean. But do not worry about words like that. I'm not going to ask things like that this is that one question, so, and if you remember that distribution, when we start to get into the tails, that's where we have 2, right? And then 3 is really rare, and then 4 is even more rare. And I think that's where it's like 2.5 is pretty significantly larger than the mean. Okay, so that's where that was coming from. But you wouldn't have anything else like that would be kind of that tricky. Okay.
No, but it's good to know, because you're right. Now that you gave me that example of like that normal distribution something, it gave me an idea of why it would be above the mean.
Right. Okay. Yeah, good. Yes, a lot of these kind of visualizing that distribution in your head, if you're able to, or you guys you have all your stuff around, you can have your notes there, and looking at that distribution, that can kind of maybe help you visualize and understand what some of these questions are, for sure. So let's see. Okay, so now I put in here some of these questions where we're practicing and we're using this table. Remember our Z table that we looked at? Okay, so those questions would be using this, and we'll go over it again in just a little bit so we can practice, and then we have a whole little fun thing here to do. So this is something about like psychological or educational tests. Usually those are all standardized, right? The MMPI is a gosh, it's a really cool test that we don't have, you know, time to talk about it here. But this is a test that is under lock and key. Psychologists aren't allowed to administer it on their own. They can administer it, but you have to send in the results, and then you get them sent back to you. They can pick up on when somebody is lying. It picks up on when somebody's trying to make themselves look better than they are. It also picks up on people that are trying to fake an illness. And so they're used in court, like in insurance fraud claims, when someone's trying to claim disability and they're not. It's also used like for FBI, all of those, FBI, CIA, when you try and make yourself look a little bit better than you should, because you think that that's what you're supposed to do to get into the FBI. Super fascinating test. So the MMPI, all right, it's designed to have a mean of 50 and a standard deviation of 10. Okay, so we're going to go through and we want to calculate Jimmy's Z-score, okay, and Susie's and Linda's and Bob's. We're going to get a Z-score, and then we want to see what their percentile ranking is, okay? And so this part is what I didn't go over with the Tuesday class, and unfortunately was not able to put up on the Zoom, on the YouTube. So we'll cover that right now, okay? Just by looking over this, is there any immediate question that you guys are wondering? No, I'm not really sure. I don't have a preference or even a conceived notion of how I would want you to answer this and turn it into me. I guess, I mean, I do want to give you credit for it, and I think it's a good opportunity to get another, you know, homework grade. So you could just, if you wanted to, you could print it out and you could circle it and answer it and take pictures and email it to me. Okay, you can do that. If you just wanted in an email, just to type out the answers, I'm okay with that too. I don't have, you know, this is the first time doing that, so I don't have a preference or anything like that. Okay, so however it is that you want to turn back in these answers is totally fine with me. Okay, so if you wanted to write on the paper and take pictures and email it to me, or if you just wanted to type out the answers right now, either one is totally cool with me. Okay.
It's already kind of late to tell you, but like when it's question 10 and below, do we use the ones in the books?
Yes, these questions right here. Yeah, Christy, we're going to use the tables in the book, and I'm going to go over that right now. Okay. But yes, so 10, 11, 12, and 13, you have to use pages 386 and 387. Okay, there's no way you would be able to figure that out on your own. Okay, there's yeah, you have to look at those values in the table. Okay, good question. Good question. Thank you. Okay, so let's go. What I'm gonna do is kind of go through the slides, and I'm gonna go back and forth between some of those questions, just so we make sure that we know how to answer, you know, each section. Okay, if that makes sense. So let's get these up. Okay. Very important right here, this formula for the Z-score, right? That's going to help you to answer those very first questions all about the IQ. Let's see. Sometimes it lets me do a split screen. Did I already close it? Oh, there we go. Although we kind of, we block it a little bit, but I'm going to minimize us. Please just speak out and yell it out if you have a question, okay? Because I can't see you now. Okay, so if you have a question, just shout it out. Okay, so all of these questions right here, 1 through 5, you have to use the formula to find the z-score. If y'all can hear my dog, I'm so sorry. I don't know why he's going crazy. So, okay, so just to see, let's see, I'm not going to pick that first one. That first one's a little bit too easy. Let's do the second one, okay? So I'm going to do the second one. So Z would be equal to, you always put the raw score first, okay? So it's telling you here in the question, what z-score corresponds to a raw score of 76. Have 76 first minus the population mean, which is told to us that it says right here, the average score. Oh, it won't let me write on it. Oh no, sorry. So the average score of an IQ test is 100. And we're going to divide that by the standard deviation, which again, it tells us the standard deviation is 15. Okay, so I'm getting my calculator here. Oops. Sorry, something popped up right when I was trying to get my calculator and it took me to the wrong thing. Okay, so 76 minus 100, I get negative 24. Write this right here. 24.
Can
Do
you
what?
For which question?
Number 2.
Okay, hold on. So you do the raw score minus the mean divided by 15?
Uh-huh.
Minus 100.
Yeah, raw score always goes first, minus the mean. What's wrong?
Yeah, I got negative 24, but then when I divide by 15, I get negative 1.6 as the z-score.
Okay, divided by 15. I get that also. I get that also. So that is, it doesn't tell us the person. This is this person's z-score. So negative 1.6. Okay. So let's talk about that and let's think about that in terms of a distribution. Okay, if we had the distribution here and we had 0, looks like a 6. If we had the 0 here, which is the mean, but we also know that the mean is 100, right? Okay, we know the mean is 100. In z-scores, right, we'd have maybe -1 about there and -2 maybe there. You know, forgive me, it's not perfect. That's really far out for a -2, but that's okay. And the -1.6, I'm going to do a different color just so we can see it a little bit better, would be maybe right about here, right? That -1.6, okay? They're below the mean. Think of an IQ of 76. If the average is 100, and our standard deviation is 15, right? One standard deviation below 100 would be 85. And so they're even below that, okay? So a negative 1.6, you know, makes, well, I mean, obviously it makes sense, okay? But when we're thinking about it, when we're visualizing it, 76 is pretty far below 100, okay? So we're gonna have a z-score that's pretty far down there. And then since it's below the mean, it's gonna be a negative, okay? How does that go, kind of thinking about it and talking about it like that? Oh, yeah, okay. And then you have
Sorry.
those, oh, go ahead.
Sorry. So the answer, do we just put the number we get, like negative 1.6, or do we
Mhm.
put it's below the mean?
Oh, just negative 1.6 is perfect.
Okay.
Yeah, okay. Yeah, good question. Good question. So negative 1.6 would be the answer for number 2, right? We won't calculate it, but look at number 3. Is 3 going to be a negative z-score or a positive z-score?
Sorry, can you repeat that?
Positive?
On number 3 over here.
Number-
Christy, you said a positive. Remember, a positive is going to be if it's over the mean.
Oh, okay.
Do you see
Oh,
that now? So
Yeah.
it's 97, so it's going to be below the mean.
it's going to be negative.
It's going to be a negative.
So automatically, you can actually see from the raw score that it's going to be within, like lower than the mean, or
That's exactly right.
okay, below
Yeah.
average.
Do you see that? That's exactly right, because their raw score is 76 and they're telling us the mean is 100. We already know that they're below the mean and it's going to be a negative z-score. Okay. 97, it's below the mean, so it's going to be a negative z-score. Is 97 far away from 100?
Mm-hmm. Wait,
Is it-
sorry?
Is 97 far away from 100?
No, it's almost there.
It's almost there, right? So that z-score is going to be a really small number, right? It's going to be really close to 0. Okay, it's going to be negative, but it's going to be really close. Pretty much the same with this one. What value is this going to be, positive or negative? The 101.
That's going to be a positive.
That's exactly right. Okay, it's going to be a positive z-score because it's above the mean. See, you guys are doing so good, right? You guys are doing so good. So I'll leave that. Unless you guys, do you want to do another one? Do you guys feel pretty good with that, with the z-scores? Okay. So I think just remembering always the raw score first.
Yeah.
Raw score first minus the mean divided by the standard deviation, and then you're going to get a value, right? Whether it's negative or positive has to do with whether that raw score is below the mean or above the mean. Okay. Okay, let's see. Those, I think you can do those, okay? But if you're working on these little multiple choice ones, these questions, as I like to say, the words, not the math part, if you have a question about those, please, email me, whatever it may be, okay? So if you have a question about those, but I want to hop over and get to these real quick. So finding these proportions, okay? Finding the proportions. So I have one of these slides here that has our Z table on it. Okay, that one will work. I didn't know if I should have one, the other page. Let's see, I'm gonna try and blow this up here. Okay, ooh, look at that, nice. So our Z table, okay. Just to look at it again, because I know it's been a week, right? To look at it again, remember our A column right here is our Z-score, okay? And so all of our A's, and it's highlighted in the blue there, all of our A columns are our Z-scores, okay? B column is the mean to the Z that you're looking up. B column is the proportion between the mean and the Z. And it even tells you here, right? It shows you, it tells you. Let's see, I can't make that bigger without writing on it. Let's see. Do you see right there? It tells you the mean to the z. Okay, mean to the z. C column is the z to infinity. Okay, it's the z to infinity. And what that means, it's from the z beyond in the tail. Okay, so I'm going to try and color real nice here. This would be C right there, and this would be C. This would be the B column, and this would be the B column. Okay. A is just whatever Z you're looking at. Okay. So remember, if you get confused, I mean, you're going to have your notes and everything too, but even the table is telling you, right? It's giving you all these hints. I know it's a little confusing to look at, but it's trying to tell you, you know, here's the information, okay? I didn't want to do that. Okay. All right, so let's look at number 10, okay? It's asking us what is the proportion between the mean and a z-score. Right there, what column are we going to be looking at if it's saying what is the proportion between the mean and a z-score?
B.
We're going to be looking in B. Yes. Okay, so now the z-score is 1.41. So we have to find 1.41. Excuse me. And here we have it right here. 1.41. Okay. And so it's telling us we already know the proportion between the mean and a z-score, and we need to look at B. So there it is, 0.4207. Okay, it's that simple, right? Don't make it more complicated than it needs to be. The only the hard part about it, I don't want to dismiss this. You know, it's new, it's different. Who talks about z-scores out on the street, right, with your friends? But we just listen, right? What is the proportion between the mean and a z-score? It's just knowing that that is column B. Okay, and again, we don't really have to even remember that, right? It tells us right here, from the mean to the z. Okay, from the mean to the z. So right there, number 10, that's our answer. Okay, the proportion in the tail beyond a z-score of 1.41. Which column are we doing there?
C.
C, right. Right. C column, the z to infinity. Please tell me the answer's there. Okay, it is, right? In the tail beyond a z-score of 1.41. You know what I like to say? Because C column up here has z to infinity. I like to think of, oh my God, I just lost his, Buzz Lightyear, right? He always says to infinity and beyond. Okay, so tied together, whenever you hear that word beyond, think of Buzz Lightyear, to infinity and beyond. And here's our infinity right here. Okay, so whenever you hear beyond, think of infinity and think of the z to the infinity, and you think of that C column. Okay, because what they're talking about is this right here. That z-score here, and then it's remember that that tail would continue on forever, okay, for infinity. So it's talking about what is the proportion in all of here continuing on forever to infinity, okay? Now, I don't know if we covered this with you guys. What do we do with a negative? We didn't cover this? We didn't do it. Did we do it?
We
Oh, we
did.
did.
We did. Sorry. It's basically you kind of don't pay attention to the negative, right?
That's right. That is exactly right. Okay. So I don't want to do this one. I don't want to spoil this one. Okay. I'm going to pick another value here. Let's see, this one just popped out in my head right here. I looked at this one. So let's play pretend and say I was asking you about negative 0.77. Okay, negative 0.77. So if I said, what's the proportion in the tail? Oh, no, sorry. What's the proportion between the mean and a z-score of negative 0.77?
Negative 0.77, it would be the 2794.
That's right. Okay, that's exactly right.
But it would be positive, not negative. So you would.
Yes, that's exactly right. It would be positive. So big hint right here, these with a negative, you can already scratch those out, okay? You cannot have a negative proportion of people, right? Even if we think of it this way, because we can think of proportions like percentages. So can we have a negative percentage of people? No, right? That doesn't make sense. So just because they're below the mean does not mean that they're negative and in any way that they don't exist. They exist, they matter, right? They're there. They just happen to be below the mean. Okay, so when we see a negative, like this example right here, example 12 and 13, okay, that's fine. We know it's negative. We know they're below the mean, but we're still just going to look at that value, 3.23. We're still just going to look at B column, and we're just going to report what those values are. We do not have a negative proportion. Okay, so just like Natalia just said in our example of negative 0.77, that proportion between the mean and the z is 0.2794. Okay, and then that value beyond the mean would be 0.2206, right? Okay, are we good with that? We understand that?
So in the table, you'll never see a negative sign on your table?
That's right. Yeah. Now, well, good question, Susana. If you Googled like a normal distribution or a z-table, and you're getting different images, all these books, all these publishers present the table in different ways. They might have negative z-scores, but they will never have a negative proportion, okay? And it's almost like it's a waste of ink, it's a waste of space and paper for them to put a negative z-score because it's not necessary. But I guess some books, some publishers might put that, I guess, just to try and take away any confusion, okay? But you would never see a negative in the proportion part. Let me plug in my computer. I don't want it to die. Okay, so that's good. Did that answer your question, Susana? Is that, yeah, okay. Yeah, I have